A is level, sequences and series. Exam preparation questions, part 4. Let's look at another example. Now, in this video, we will start to look at geometric progressions. So the sum to infinity of a geometric progression is 9 times, so to infinity is 9 times of the first 4 terms. Given that the first term is 12, find the value of the fifth term. Okay, now, if it's a GP, then the first term will be AR squared, AR to the power of 3, where the value of A will be 12. Okay, so then it will be 12, 12R, 12R squared, 12R to the power of 3. Now, let's just go to the formulas. Now, sometimes the 1 is in front, sometimes the R. It depends which one is the biggest. But because it's infinity and it can be between this, I think it can be a fraction. So let's rather go for the 1 in front. Okay, it's not going to have an influence. Okay, and then the sum to infinity, don't forget, there I wrote down the formula, is the sum to infinity. Again, you can look on your formula sheets to find all the different formulas. Okay, so let's start with the statement. This, the sum to infinity, so the sum, there is the sum to infinity, is 9 times the first 4 terms. So it means we must just, so it's the sum to infinity is 9 times S4. That's basically, and maybe I can just put an arrow indicating that. Okay, so this is, I put the 12, 1 minus R, I don't have R, 9, 12, 1 minus R to the power of 4, 1 minus R. So I just put what I have. Now, just remember, can you see that in this case, and I can think where it will be better. Okay, so this is over, okay, let's rather put it like this. This is over this, over this. Now, do you see that the denominators are the same? And if the denominators are the same, it's almost like we multiply with 1 minus R on this side, 1 minus R on this side. So basically, it cancels out, and that's what happened there. Okay. And now I just multiplied in and I got this. And then I divide and I got this. And then I take this one over so that it becomes positive and I do this and I get 8 over 9. Now, because, and I want to make it a bit bigger, it's not always, so without going for the fourth root, because they asked the fifth term, and the fifth term will be, can I just show, this was 1, this, okay, let's just get a pen. This was 1, this was 2, this was 3, this was 4, and then 5. So the fifth term will be R to the power of 4. And that's why I'm leaving it like this, because it's not the answer. And now I go for the fifth term. So Tn, again I write down the formula from the formula sheet, or I can recall it. And then I get 12R to the power of 4, because I have A. And then in the place of that R to the, I just put 8 over 9. 8 over 9. And then I multiply it in and I get 10 and 2/3. Okay. And that's how you do it. Really not that difficult. Okay. I want you to stop the video and I want you, there's also still other examples. But what I want you to do is first do 1 and then do 2. And then as soon as you did that, I'll show you the other examples on the next page. Okay. Going to make smaller, and again you can stop, do 1, check, and then continue like this, and then do 2. Okay, let's start. Number 1. The third and the fourth terms of a geometrical progression are 48 and 32. Okay, so let's just start. The third term is 48. Okay, let me rather, I just want to say like this, of a geometrical progression is 48. And the fourth term of that GP, and that is going to be 32. Okay. Find the sum to infinity of these progressions. Okay. Now, just take note and think a little bit. Not just always do think. you can get the value of r because this is two terms that's following each other, consecutive terms. So you can get r by saying T4 divide T3, which will be 32 divide 48. And that will be 2 over 3. Okay. Now, I can now get the value of a by putting it in any one of that. But let's go for 3. Okay, just remember Tn equals a or n minus 1. Now, T3 will be a. So, in the place I don't have a, okay, I have T3. Okay, I actually want to put it in, but okay, I'll put it in now. So, a or, and it's 3 minus 1, but I have T3. So it's 48 equals a. I have r, it's 2 over 3, and it's to the power of 2. So it's 48 equals 4 over 9a. And if I simplify that, I divide by 4 over 9. I divide by 4 over 9. So multiply the reciprocal. 4 over 9 or 9 over 4. And then I get so that the value of a is 108. Okay. And now they are asking me, find the sum to infinity. Okay, so I'm just going to use another color. So the sum to infinity, don't forget the formula a, 1 minus r, not r minus 1. Okay, so it's 1 over 8, and then 1 minus, and remember the value of r is 2/3. And that is going to be 108 divided by 1/3. And that is going to be 324. And that will be the sum to infinity. So really, really not that difficult. Okay, that was number 1. Let's do number 2. Okay. Okay, let's start with number 2. A geometric progression is such that the second term is equal to 24% of the sum to infinity. Find the possible values of the common ratio. Okay, so let's start with that statement. The second term is 24%. So percent means out of 100 of the sum to infinity. Okay, so with that, I'm going to start working. Now, the second term is going to be AR, and it's 2 minus 1. Leave it rather a fraction. Don't make it a decimal because we are going to work with a fraction on this side also. So A over 1 minus R. Okay, so this is going to be AR. Okay, now if you want, you're going to divide there with 24 over 100. And that's going to give you a 1 minus r. I could have already multiplied. So this is going to give you, do you see? Because it's, let me just do it on the side. I know I'm sometimes a bit long, but it's just that you follow, for everyone to follow. So I multiply with the reciprocal. So basically, it's going to be 100 AR over 24. And that's going to be a over 1 minus r. Okay, put a bracket. It's one term equals one term, so I can cross multiply. So I can get 24a equals 100 AR 1 minus r. So it's 24a equals 100 AR minus 100 AR squared. Now, do you notice that there's a A, there's a A, there's a A? So basically, I'm just going to divide all the terms by A. So I divide A, divide A, divide A. That's the wonder of an equation. You can do anything with it as long as you do it with all the terms. So what do I'm going to get? I'm going to get 24 is equal to 100R minus 100r squared. And now I see it's a quadratic equation. Excellent. So now I'm just going to rearrange it. So let's make it 100r squared minus 100r plus 24 and that is equal to 0. Now, I can divide 2, I can this, but I think if I divide all of them by 4, then I will get, because I want to try to factorize it, minus 25r plus 6. Now, if you struggle, then don't, with the factor, because it's now a bit more complicated, then just go for your formula. Minus b plus minus that formula, b squared minus 4ac over 2a, to find that value of r. Okay, but this can factorize. This is the nice thing. It factorizes nicely. So let's just factorize it. I can say this is going to be 5 and 5, and it's going to be 3 and 2. And let's just check. This is going to be 15 plus, because it's group A, 10, and that's 25. The signs are the same, and it's negative, negative, and it's r, r. So basically, I'm going to get 5r minus 3, 5r minus 2, and that's equal to 0. So I have 5r minus 3 equals 0, or 5r minus 2 equals 0. So therefore, 5r equals 3, or 5r equals 2. So I divide 5, divide 5, divide 5, divide 5. So I'm getting, and that's why they said, find the possible values of the common ratio. So it was not 1, it was 2. So therefore, r, I always like to end rather in red, r equals 3 over 5, or r equals 2 over 5. And that's my final answer. Okay, let's do the next one. Now, again, as before, I'm going to stop the video after number 4, but I want you to do the same. I want you to try 3 and then stop, check, try 4, stop, check. Okay, so I'm going to start with number 3. So let's start. The 5th, the 6th, and the 7th term of a geometric, so it's 5th, 6th, 7, of a geometric progression is 8k minus 12, 2k respectively. Given that k is negative, underline, find the sum to infinity of the progression. Okay, now I like to write it's the 5th, it's the 6th. I like to put a bit structure into it. Oh, no, definitely not 5 again, 7. So it's going to be 8k, it's going to be negative 12, and it's going to be 2k. Okay, now basically, because I have all three, there's a variable. I can say, and can I just show you now, I know that to get the value of r, it's always the front divided by the back. Oh, sorry, let's just get for that back. So basically, I can say, can I just show you here? I can say that T6 divide T5 must be equal to T7 divide T6, because that is going to be equal to the value of r. Okay, so let's fill it in. So negative 12 over 8k equals 2k over negative 12. Okay, now I can start, and I can start cross multiplying. Okay, so let's just see. If I say this one times this 12, I'm going to quickly do first that one. So this is going to be 144, and this is going to be 6k squared. Now let's see if it's dividing by 60. Excellent. So I get k squared is equal to 9. So I'm getting, I take the square root. So therefore, k is equal to plus minus 3. Okay, but let's read the question. Given that k is negative, so no, then it's better not to say there. It's better to say k is plus minus, but in parallels, but k is negative. Therefore, k is equal to negative 3. Okay, but this is not the end of the question. The sum to infinity. So let's just go for S to infinity equals a over 1 minus r. But before I do that, I must first find the value of a. So let's just quickly go and let's see to find that. I just quickly want to check something there. Okay. So let's get, because we don't have r, we don't have a. So before I come to that sum to infinity, let's just take the terms, the three terms again. Okay, I'm just going to. So it was now, the three terms was T5, okay, T5, T6, and it was T7. Now, if you look at this, this was 8k. Okay, now this was all right, negative 12, and this was 2k. So if I substitute it in, then it's going to be 8, and now it's negative 3, and 2, and it's negative 3. And this is going to be negative 24, and then negative 12, and then negative 6. But remember, this is not the first term. This is the fifth term. So just take one of, to get the value of r is not a problem. So r can be T6 over, okay, T5, which I already have there. I could have already, because I worked it out there, but it's fine. Let's just do it. And it's going to be negative 12 over negative 24. So the value of r is going to be a half. And now I want a. So take T5. Remember, it's a or, okay, I'm doing a little bit long. So if I'm going to take T5, then because I want the value of a, so I'm going to say negative 24. I want a. I have r is a half, and that's to the power of 4. So it's negative 24 equals a, and this is going to be 1, and 2 to the power of 4 is 16. Okay. And this is going to be negative 24, oh, sorry, let's just go and do it. 24 over 1, and this is going to be a over 16. I'm doing long. Let's follow quickly. So this is going to be a, so I cross multiply a, and this is going to be, and the value of a is negative 384. Now I can go back to this formula. So I had to first work it out. So let's just go back to my green. So s to infinity equals a, so negative 384 over 1 minus a half. And that is going to be negative 384 over a half. And then the value of s to infinity is going to be, so therefore, let's just do it like this. Therefore, s to infinity equals negative 768. Okay. And that will be your answer. Okay, that's not difficult. Let's do the final one. Okay. And I see they laugh. And this was, I took it out of the last, I was checking the last few Cambridge international examinations. So about 4-5 years. And I see they love asking the GPs with the sum to infinity. Okay. Or they love combining it because this is where it comes, but not asking individual. But I'll show you in later videos how they love to combine also APs and GPs. So, and how we go to practical. So that will be the 2 videos still. There will be 6 videos in sequences and series. Okay. So let's just go for this final one, which is number 4. Okay. Number 4. The first and the second terms of a geometric progression are p and 2p, respectively, where p is a positive constant. Always, you can even underline it with red. The sum of the first n terms is greater than 1000p. Show that. Okay, so let's start. The first term and the second term. And that's going to be p, and that's going to be 2p. Okay. And now I'm just going to go up, and it's actually a very short sum. So now I'm just going to say out of that I can find my value. So what will be the value of r? T2 divide T1, which is 2p over p, and my value of r will just be 2. Don't forget that my value of a is p. Okay, and now I'm just going to say, they say the sum of the first n terms. Now r is, if it's bigger than it stands, then I'm going to use the formula s, show you, n equals a. Then the big one I put on front, so it's r to the power of n minus 1 over r minus 1. And if I start with r, I start. So if the r is smaller than 1, then I put the ones in front. So I put the one that's the biggest in front, either r or 1. Okay. But now I'm saying that this Sn show that the first n is greater than 1000 p. That's what I want to 1000. I only have 100. Okay, so let's just go in and we put it in there, and we're going to say a r n minus 1 r minus 1. Okay, so basically I'm going to say in the place of a I put p, in the place of r I put 2, and it's 2 minus 1, and it's 1000 p. Okay, and now, okay, let me just simplify. I know I do a long step, but as I said, especially in the videos, I don't want everyone to follow. So you can always do shorter. Okay, so because this is 1. So basically, I divide all the sides, I divide by p. Okay, so if I divide by p, and I divide by, let's just get it correct, divide by p, then I'm getting 2n minus 1 smaller to 1000. Okay, but what is the question asking me? Okay, so I'm going to continue by saying 2n is bigger, sorry, not smaller, than 1001. And I think that was the statement. Look there. 2n is bigger than 1001. Show. So if they say show, then they want you to end with that statement. Okay, not to start with it, to end with it. And this is the end of this video. In the next video, I will look at combined examples of APs and GPs.